We have one other excellent presenter here, Dr. Brouder.
All right, thank you very much. I will be reiterating several themes that have already come up. It is a pleasure and an honor to be here to talk about sustainable intensification. It is a topic that is near and dear to me. I've heard comments last night and again this morning regarding the need to define what it is, because I think in the theoretical context, it's wonderful and it's something that we can rally around. Who wouldn't want to produce more efficiently while working within the biology and an ecology of a field or a landscape or whatever, and ending up with wins in all directions and no losses? That's a wonderful concept. The practice is much more problematic, and the problematic aspect of it is directly linked to the fact that it's locally realized and it's locally driven. And so what is sustainable or ecological intensification versus farmer practices locally derived? The other things that I would like to hit on as themes that have implications for where research universities can certainly contribute, U.S. research universities, is Sahara mentioned the notion of toolkits. We have toolkits of technologies. From my perspective, unfortunately, we're still putting these together into panacea packages rather rapidly, and then assuming they'll have a broad footprint. The bread and butter of traditional extension is understanding experimental results sufficiently to characterize the inference space so that you can say not only what happened, but what would happen someplace else if you were to do X. And that's the diagnostic and recommendation procedure, and there's a lot that needs to be done there. I'll finish up with some discussion of research needs and understanding the coupled natural resource management opportunities, and opportunities stem from problems, so it'll be a discussion a bit of the problems and where opportunities lie for research. This invitation is a bit fortuitous. It comes on the invitation by the Independent Science and Partnership Council to take a look this past fall at the conservation agriculture package as it's being delivered, and I don't have a pointer, but you can see in black zero tillage, mulch, and rotation are the pillars of conservation agriculture. And what I and a colleague from Spain were asked to do was to look at what is the evidence that there are positive and or non-negative yield impacts, and from South Asia and from sub-Saharan Africa. And we didn't have very long to do it, so these are sort of preliminary cuts at it. But what I want to highlight out of this experience is that we're dealing with very complex systems, and it may be self-evident that not all factors matter equally everywhere in space and time. But what we're not doing a particularly good job at is this issue of the mechanisms. If we understand the mechanisms in a quantitative way, then we can begin to understand driveways, pathways, feedbacks, etc. And for the package of conservation ag technologies as kind of being implemented broadly right now throughout the international centers and in some in-country activities, we can't really understand or predict the outcome everywhere in time and space, and that has negative hugely negative implications as we're seeing disadoption at very high rates. And you can ask questions, what do we know about effects? Are they additive? Are they multiplicative? We know there are red arrows and green arrows and all kinds of stuff on this graph, and that's because when you do something, there are many ways of doing it, so zero tillage, machinery, whatever. There are differences, and what you want to do is end up with promoting good green arrow type things in the short and long term, and you don't want to have the reds, but unfortunately you get both. So just, you know, we were mandated to look at the main CGIAR mandate crops and to just do a quick assessment of what do we seem to know from the published literature. So this isn't going into ongoing projects or anything like that. And to look at priorities for future agronomic research, et cetera. And we looked at all types of studies, reviews, surveys, on farm, on station. I'm going to come back to the importance of reviews. That complex diagram, those sorts of diagrams can always be broken down, and this is where your science comes from, and your experimental and your hypotheses. It can always be broken down into, you know what the interventions are, you know the yield drivers, the things that you're going to be tinkering with via those interventions. And where we seem to have difficulty is asking the hard questions about the impact on drivers and their importance in a positive yield effect. You know, so you are expecting with no tillage to have an impact on water relations, and you would like to increase water productivity, more crop per drop, right? But there are a whole lot of other factors that are implicit in that achievement, and if you don't study those, you may end up, and we have ended up, very surprised by the outcome. And it's doing a little bit more work on the upstream end to understand and to research what your water productivity hypotheses are that will get you further down the line, I think. Just as a way of kind of characterizing the state of the science, when you go in to look for evidence for an impact of one thing directly on another. So more than association, you're looking for causation, and more than causation, you're looking for quantitative degrees of causation. What you'll find when you start looking at the literature is that you end up with fewer and fewer papers as you get rid of them because they don't meet your criteria for addressing your question. So this is just an idea of the number of papers we found and were able to use. Not too much data, but I think it's important to look at a little bit of data because it's illustrative of the science that needs to be done. You have time going along the x-axis in years, and then you have change in yield from practice implementation. So if you are at 0, you have no effect on the x-axis. If you are above 0, you're positive, and if you're below 0, you're negative. And you see a lot of dots below 0. The question that comes up is, can we untangle the inference space to increase the probability of a rapid, because you don't want people to have to do something for a long time before they get a benefit, because they won't, and positive outcome. So all those dots that are below 0, you don't want those. And what we found is, based on what's out there, we can't really untangle it. And it's because in its present state, the science is not comprehensive enough to untangle the confounded biophysical factors. If you want to go even farther and say, well, beyond yield, we want to look at environmental metrics, sustainability metrics, and we want to show something good, neutral, whatever happened to them, it's even worse. The state of the science is even more problematic. Okay, so what we found was that when we looked at the papers, we could find from that very complex set of pathways and feedbacks, we could find things mentioned. When they were mentioned, sometimes there was an indication of positive, negative, oftentimes there wasn't, but typically there wasn't enough data presented so you knew the actual cause-effect relationship. Okay, switching gears a little bit. Gates Foundation had a convening in November on the role of perennials or perennial grains, legumes, etc., for improving smallholder farmer aspects of food security in sub-Saharan Africa, South Asia, etc. And I went in from the kind of the ecological perspective, and again, you can walk through this, and this doesn't show up very well. I apologize for it, but what I want you to take home from this is that we can hypothesize an advantage. We can identify the attributes through which those advantages are going to be realized. We can identify a hypothetical mechanism. But when we get to the realizing the benefit, there's always a yes-if statement. And we need to pay attention to the if. If we do not look at the ifs that modify the yes, we do not get the result. And we can do a good job anticipating it. I think the last one here at the bottom, it says, yes, can you get better carbon sequestration? Yes, if you have nutrients. Why do you need nutrients? Well, it turns out if you want to sequester carbon in the soil, that carbon has to go with a quantitative amount of nitrogen, phosphorus, and sulfur. So if those nutrients aren't there with the carbon, you're not going to sequester carbon. Another angle on this, same sort of thing, when you increase an application to get that carbon sequestration, to get that better growth, you increase the opportunity for NLOS through a variety of mechanisms. Do we know what those are? Do we know enough about those mechanisms to predict where you will have greater or less loss with the implementation of a practice? Okay, this is more of the same. As a plant nutrition person, we love to talk about law of the minimum, hence the barrel, but this is our bread and butter. You can increase nitrogen, but if you don't increase water productivity, you are not going to gain any benefit, and your efficiency goes down. Very common, but lost in the shuffle of science when we try to think about what matters. Okay, one of the last thing that we were asked to do as part of the ISPC study was to make some assessments on quality of science and how would you rate, is this a high study, is it quality study, or is this a low quality study, for the purposes of meta-analysis. So Gabisa brought up the need for meta-analysis for understanding investments in countries. Meta-analysis is the be-all and end-all of understanding inference space. And we know that from the medical community. That's what you do for evidence-based practice. But the bottom line, well, nobody does science poorly intentionally. At least I don't think. I mean, most of us start with the best intentions, and mistakes are common. Why are mistakes common? Because either we don't know or we don't value the full array of data that are necessary, so we don't collect, or maybe we collect but we don't report. And so when we look at research opportunities, there's a tremendous one in raising the level of the quality of science to meet multiple objectives. Field research is incredibly expensive. You want to optimize your investment on field research and surveys and all these other things by making sure when you do it, you don't have to redo it to get a little bit more data that is critical to addressing questions. Okay, gaps. With respect to the kind of the conservation agriculture review that we did, we were asked to come out with suggestions, and we did. There are minimum data sets that we should probably, and donors can insist because you have the money, that are collected, and it isn't ingrained and it isn't taught right now in agronomy what those data sets are and their importance. I think there's a need. There was some discussion about linking across projects. The need for data infrastructure and data stewardship for sharing data in the agronomic sciences is huge, and there's a need for U.S. institutions, or a potential for U.S. institutions to help immensely with that structure. The need for meta-analyses, I can talk forever about this topic, but I believe in it, and that if we don't have data sharing mechanisms, we're not going to get the meta-analysis and hence the development of evidence-based practices. When you look, we have to understand, and this graph comes from Ken Kassman, it's a bandwagon he's been on forever in the sustainable intensification arena. You have to understand the potential of the system, so this yield gap research is really critical. I would say, though, we have to extend it. It's very great to understand the yield gap for maize, but you need to understand the gap in the context of the cropping system and the farming system, because maybe you don't care if you attain maximum amount of yield for maize if that's at the expense of other aspects of your farming system. Again, understanding the coupled natural resource sort of farm to landscape scale of management opportunities. I would say that, and I think I mentioned this already, that the ecosystem services research for conservation ag in sub-Saharan Africa, South Asia, it is much less conclusive than even the yield stuff that we were looking at. And again, it speaks to the need for minimum data sets, standard operating procedures, et cetera, in experiments. There are a whole lot of other issues, but I'll close with just a comment on we know a lot about agro-ecozones. You have to blend that with the culture, and then you do want to end up with management packages, but you need to do a very hard look at your inference space. You have to consider the boundaries of your inference space, because if you don't consider the boundaries, you get into land use change issues and all kinds of unanticipated consequences. So I think I'll just end at that. I think there's a whole lot of research that needs to be done in what happens when you tweak a system by implementing a technology. And you have to look at a whole lot more things than we have been looking at. I see a lot of nods, so I clearly am preaching to the choir.
Well, that's a great panel. Thank you. Thank you.